Alright, so if we're going to talk about something today, what we really should be talking about is the solar uptick, and it's continuing. Um, I think the longest such uptick we've had since I started discussing the solar quiet, at least the Earth-facing solar quiet, and the general magnetic shutdown was about a week and a half, where we had like 22 M flares. It was like July 2012, you'll remember, and we had like one of the hottest single weeks ever recorded on this planet, and that was a big deal for us. But we have been talking a lot about how these solar upticks come, and they don't last for very long, and they don't really live up to solar max. And not that that has really changed much. The flares are exciting, when put into perspective with what we've dealt with so far at the peak of this solar cycle. Even today, I know you haven't had the internet most of the day, Billy, but we had what can only be described as a triple peaking then long duration M flare, where the long duration ending portion of the M flare lasted about an hour. We hopped back from the departing spots being active to the incoming spots being active, including the one that's I'm going to say it's maybe a sixth or a seventh away from being, directly Earth facing. The number of that sunspot, if I can pull it up right here, is 1882. Interestingly, we're going to have to look for the slit jaw images on that, because Iris is scheduled to be watching that active region right now for flares, specifically for flares. If you go to the Iris website and you go up to look at the top, where you're pulling up the slit jaw images, you can click on planned, and it'll show you their planned observations. But anyway, so we had some more eruptions today. The last one from 1882 is probably going to be Earth-directed. But, we've taken two minor interplanetary shocks from these M and X-class flares, tough to tell which was which. Had no geomagnetic storms, barely any signature on the solar wind. The solar wind speed didn't even hit 400 during the interplanetary shock we took last night. And still, we've had 3 X flares, 2 X1s and an X2 for this uptick, and that's just not cutting it for solar maximum, is it? I mean, you remember some of when we were doing, I think it was 2011, when you and I were really digging deep into the flares from last cycle.
Yeah, it's cycle 23. In fact, the largest flare recorded, I think, in that cycle was, I'm looking on Wikipedia, 17.2, an X17, which happened on the 28th of October, 2003.
Yeah, there was also one that they said that they estimated could be over X40. Their machine stopped reading it at like X28 or something. It wasn't Earth-directed. It was what many called a shot over the bow that Ed Dames talks about, the one that would precede the kill shot. I actually think that was from last cycle as well.
Yeah,
but I know we had a bunch of X10s and things like that, right?
Absolutely. Yeah, well, actually, initially, we had several at that time.
If you have the list,
23. The November 4th, 2003, initially measured an X28, but was later upgraded to an X45.
Wow. Well, hey, if you have the list up there, do you have like the list of the biggest flares we've ever recorded?
This is just for cycle 23. We can look it up right quick.
Okay.
In fact, the October is showing into the late October 2003 event, which was the X17. Auroras were visible in South Florida and Texas. G5 level magnetic storm.
Yeah, I definitely remember. I remember that night. That night. I was woken up, and my dad told me to look out the window.
The November 4th storm was X28 upgraded to 45, and they don't give any.
Well, that one wasn't.
Low latitude or high latitude auroras were visible.
That one was barely even. A glancing blow. That was not even close to Earth facing. But I think the 4th or 5th largest flare that humans have ever recorded was like an X14, X15, something like that. and it happened right in the middle of the last solar cycle, like 2006. I mean, solar minimum, excuse me, right in the middle of the last solar minimum, 2006, 2007, something like that. And so, I mean, we still haven't seen anything close to that. I mean, you take a look back at how our solar cycle started. We had an X6, we had a couple of X3s, but since November of 2011, when you and I started talking about there being kind of a shutdown when these spots face Earth, we just haven't really seen much. Now, here's a point. Here's a point. A positive point for us. Something that we talked about with this Earth-facing quiet, the extra long and extra low solar minimum, and the pitiful solar max so far was Earth's collapsing atmosphere. And anybody who needs a primer on that needs to go see Energy from Space, or They Want to Blame You. But we haven't been getting the flares that we need to keep our atmosphere from collapsing. And a few people who operate radios were saying that they were picking up signals that they weren't used to getting, that they thought that all the recent flaring had at least shown some activity in terms of our atmosphere height. And if we had been getting things like M3s, M4s, maybe an X1 here and there for the entire solar cycle, we would not even be talking about a collapsing atmosphere because it wouldn't be a problem. And now that we are in about a week's worth of solar uptick, maybe this will continue. I think that it'll probably quiet back down again. We'll probably have more upticks in a few weeks, months, or whatever. But this is the kind of thing where if we had this the entire solar cycle, we wouldn't even be discussing a collapsing atmosphere.
Yeah. Even comparing this to 1859 cycle, I forget what cycle that was. Solar cycle 10, I think, the Carrington event. It's extremely weak.
Yeah.
For a solar cycle. It can be compared to that one.
Oh yeah, and
at this point.
Yeah, I see where you're going with that, and I should definitely mention that part of seeing an X14 in the middle of a record low solar minimum, and part of knowing that the Carrington event happened during a very pitiful solar max cycle. I definitely need to state for the record that none of this solar magnetic shutdown, the weak flares so far, precludes the possibility of an X30 tomorrow. These things definitely can happen at any point at any time.
Absolutely.
However, have you taken a look at the solar wind recently? And actually, you know what, Billy, go ahead and pull up the solar wind for a second while I describe something else I'm looking at. For anyone else who's looking, we are right now in between We're right now in between the flare events here. I'm looking at the 6-hour goes. It is right in between 20 and 2100, just coming off that long duration M flare and just now coming back up. And the protons, the high energy ones that we use for polar radiation storms, also known as solar energetic particle events, we're almost at storm levels here with some sustained high energy proton activity. But you've got the solar wind pulled up now, and you can see that, if you go and you actually click on the 24-hour data or something, you can see the interplanetary shock. It sticks out like a sore thumb. And if people are listening to this too far off to catch it on the 24 hours, just go watch the news from today, October 28th. This interplanetary shock sticks out like a sore thumb, and it's barely even a CME. That truly is the definition of a squirrel fart right there. And it's not like, we're just seeing, solar wind under 300 kilometers per second for the first time. We've now been able to consistently say, hey, wow, look at this weakness in the solar magnetism that's pushing out the solar wind. This is actually happening. The stuff that we were talking about in 2011 and 2012, it's actually happening more and more now. We have had some points where it went really, really low. I wish that, Don't Fear 2012 was around, or we could get Brody to hop on the phone with us. I think that we actually set a new low record for solar minimum. For solar wind speed just a few months ago. It was like 240 or 230 something. But anyway, this solar wind is pitiful for solar max or anything for that matter. You only have to go back to the, how to watch the sun from the middle of May. And what I said then was accurate, that we expect the solar wind speed on average to be between 300 and 350 kilometers per second. It's considered low if it dips down below that, and it's been sustaining levels well below that. And I think it's all indicative of this solar magnetic shutdown that we keep coming back to over and over again. It doesn't mean that there aren't going to be flares, or perhaps even the possibility for a really big one. And it doesn't mean that the ultraviolet irradiance is going to stop, the sunlight, the things that the plants use for photosynthesis. But this is the weakening of those solar magnetic fields that we use as kind of the nexus for all of the truth that we try to uncover in what's happening with the solar system. I mean, we started with that initial question, why does it look like the sun is losing so much energy? We should have asked electromagnetism, especially now that we know that Venus, Mars, Jupiter, Saturn, and Uranus are all changing so much more than Earth is. You want to talk climate change and things like that. If half of those of any of the changes happening on those planets happen on Earth, there'd be millions of people dead already.
Yeah, without question.
And it's very interesting. I wish we had the ability to detect and sense a lot about the magnetic shields of some of these other planets, given that the Earth's is weakening according to the WGC for geomagnetism, the WDC for geomagnetism in Kyoto, Japan, and according to NASA, our magnetic shield is weakening, along with the sun's. I really wish we could know what was happening to the other planets as well. This, what we're seeing right now, the fact that the solar wind is very, very slow, very, very weak, even with interplanetary shocks coming and the sun having an uptick, which it absolutely is right now. But with that solar wind so weak, and with this uptick that we absolutely are having right now being so weak in comparison to the solar maximum, I mean, even just weak compared to the way this solar max started back in 2011.
Absolutely. Compared to the close of the previous cycle, the sun was a lot more active. Around 2008, 2009, before it shut. It almost they went into the deepest solar minimum, I think, in a while.
Mm-hmm.
It went almost a year without a sunspot.
Yes, absolutely.
But before that, 08 and 09 or early 09, it was it had a pretty good cycle. Last cycle, 22.
You mean do you mean 98 or 99? Yeah. I assume you didn't mean. Yeah, I assume you didn't mean.
22.
Yeah, I assume you didn't mean 3 years ago.
Or 23. I'm sorry.
Yeah.
Yeah, we're in 24 now.
Yeah. Well, we lost some Earth orbiting satellites, some weather satellites.
Yeah, and they fully admitted that was because of due to an increase in our atmosphere. The atmosphere gets. They had it on spaceweather.com.
Yeah, I remember that. There's definitely saying that had something to do with it. I think one of the satellites, short-circuited, which, I mean, just classic over-electrification, solar event, whatever. I do think the other one got ruined because it was a low-orbiting satellite, and we got pounded with all those X-flares in late October, and our atmosphere increased in size enough that it increased the drag.
Drag, that's what they explained it as.
Yeah, that was it.
Increased drag on satellites.
And so,
the fall.
Literally, just 10 minutes of research about what the last solar cycle was like, the last solar maximum, and you realize that.
Yeah, where did this one go?
Yeah, where did this one go?
What happened to this one?
Yeah, and I find myself here really, really hoping I have the opportunity to say everything that I've been talking about was wrong. It's over. We're back to solar maximum. The atmosphere is no longer collapsing. It looks like the solar magnetic fields are strengthening. Wow, wouldn't it be great if we could say that? But this type of flaring needs to continue, and it probably needs to get a little bit bigger. We need to see improvements in the solar wind, in terms of the energy from the solar wind. And until that point, we still have to kind of stay on this train, stay on this one track where everything, even the high points for the sun, all point towards a magnetic shutdown.
Certainly does. Certainly does. I hate to say it, but that's fearful to me. I mean, you know, when we see the temperatures this winter, will tell the tale, you know, of the connection.
Well, absolutely.
Between our solar cycles and our weather, and whether, you know, this may actually be the ice age or a minimum ice age.
Well, you know,
in the works.
You know, I've held the belief that we hopefully still have about a decade left until we really get, you know, into the nitty-gritty of the ice age. But
yeah.
I mean, we're already seeing, and this is stuff that we talk about every week and Fly on the Wall. You know, the ones on Saturdays when we get everybody in here. We talk about these crazy flooding events. How, I mean, people living in the center of the United States can know most right now. I mean, assuming that you weren't part of the Colorado disaster in September. I mean, there were parts of the summer where it was, you know, 91 degrees one day, and then all of a sudden the low moved on and we caught the back edge and it was in the 50s. You know, August is supposed to be the really hot month here, at least for me in the Midwest. It's supposed to be the hot month as long as I've lived in Ohio, and it's definitely the hot month when I lived in Pittsburgh. But it's, I mean, it was cold. It was definitely colder than July. Most of September was warmer than August for me.
Yeah, so, we had a real mild summer here.
So yeah, I mean, I
noticeable.
You know, I don't think that, you know, we're going to be in a global ice age come next spring, come next northern spring, I should say, because the South's getting ready for their summer. We just had the first southern hemisphere tropical storm of the year, or of the season, I should say. But I do think that it's very possible we could see some hints of what's to come.
Yeah, maybe a noticeable difference if it's connected to the sun, as we think it is.
Well, yeah, I mean,
and you know, mainstream scientists came out a few years ago and said that, you know, even though they had thought prior that it takes, you know, hundreds, if not thousands of years for Earth to go into an ice age, some scientists now believe that it can happen as little as a decade.
Yeah.
You know, so yeah, the next 10 years or so.
Well, you know, I still do hold out some kind of little hope that, you know, and we can say that while the sun is losing its magnetism, it does appear that the change on the other planets is of them juicing up or gaining the energy. I mean, Mars is warming relatively more than Earth, and we noticed Mars quakes, which is an interesting trick for a planet that's supposed to be seismically inactive. Venus has slowed its rotation. I mean, that hasn't happened on Earth, and their average wind speed has increased 25%. Nothing like that's happened on Earth. Jupiter lost a planetary stripe, which is a systemic climactic change, and they added Red Junior after, you know, the big red disappeared for a little while. I am hearing from some of our astronomer friends that it's definitely not dead. But the point is that, you know, it's changing way more than the Earth. Saturn changed its rotation speed as well, and that, you know, regular, set your watch. Every 30 years, Saturn gets a superstorm. Well, they got their superstorm. It was just a decade early and lasted for 200 days as opposed to just a few weeks like it normally does. All the planets seem to be on this incline, on the right side of a parabola, x equals y squared, and Earth is just lagging behind. It's not that Earth isn't changing. It's not that Earth isn't warming at the baseline. I mean, the amount of heat that's being absorbed by our oceans really is belying just how much energy is taken in by the Earth. The Earth in general is heating up. However, the effect that that's going to have, that increased energy, is what we are seeing. Higher high pressure reinforcing lower low pressure, so we get stronger storms. We get those swings from very, very hot to very, very cold within the same storm. one on the leading edge of the low and one on the back edge. You know, when we had that record snowstorm in Wyoming earlier this year, and it was just so cold coming off the backside of that low as it was in the center of the country. The leading east edge of that low was bringing enough heat and moisture to cause major tornadoes. I mean, major tornadoes. That is, I mean, we're talking about the same weather system, the same event, you know, driving opposite severe weather, all out of the one storm. And this is what we're going to see. Now, some of the interesting things that are coming around it, you know, places that see floods sometimes maybe not are going to see these floods anymore. Places that are normally dry, are they going to be wet now? I mean, I'll tell you, if we get what happened in Colorado, if that's kind of a new once-a-year thing, there are going to be parts of Arizona, Nevada, and New Mexico that are green, that haven't been green in a very long time. Did you see that? That was one of the few places that still had that, quote, exceptional drought on the U.S. drought look. And literally, the drought was erased in 3 days by that one storm. Just completely erased it.
Yeah, that's an incredible amount of water, to be honest.
Yeah, it really is. It's amazing that we can get all the way. It's amazing that we can get all the way to these minute detail changes in the weather, and start at our star. Start with the M-class flares and X-class flares that we've been seeing. I really hope that people are able to understand that connection between everything. Everything from, I mean, this was back when we were making videos called the solar system shift, or electromagnetic event, or our world is changing. I mean, that was literally just a year ago, and I look back at how little of a good understanding we had of the interconnectedness of our planet, the changes, the other planet, the sun. I mean, we basically had nothing but ideas. But now we see these ideas really, really coming true. Yeah. So I guess all we can really do is keep trying to inform everyone, keep hoping people watch the background videos, spread the information, and other than that, we'll just wait for more flaring. We just had little mini C events. Hopefully, it'll go back up and give us something else to watch as the afternoon moves on. But as it is, this solar uptick is giving us excitement. But so far, that is about it. It is putting into perspective the dire straits of our situation.
Yeah, if anybody does a rain dance, everybody will do a solar dance too.
Yeah,
add some solar activity because we need it.
Yeah. And you know, there's a lot of confusion, and I got to expect that because it is kind of a complex topic. I mean, everybody who's listening to this and understands the connection I'm telling everyone to make, or I'm hoping you guys will make, they are going to understand what I mean when I say that there are a lot of people who are at the stage of waking up where they're like, wait a minute, he's asking for flares? What's wrong with this idiot? You know? And, you know, we can't just expect people to realize that we need the flares, you know, that if we had a complete lack of flaring whatsoever, our jet stream system would collapse and Europe would be under 100 feet of ice. This isn't stuff you can just expect people to know. And also, I can't just expect people to realize that I'm not asking for a solar kill shot. We definitely, as much as some people in the comment section seem to want us to be able to hit the reset button on our planet like I used to do on Sega when I was losing to my little sister, Quiet. You know, I don't want to see that. I don't want to see a solar kill shot. I want to see a regular solar maximum where we get M and X class flares just about every day for 2 to 3 years. Our atmosphere gets a nice pump back up from its collapse during solar minimum, which is needed and expected. It'd be nice to see the solar magnetic fields bounce back after this solar pole flip and really get away from the baseline. Pump out that heliosphere, block some more cosmic rays, especially with our own shield failing here at Earth. These are the things that we're going to be watching over the next weeks, months, years. But for now, I'm going to sit here with the GOES X-ray flux on and try to do a bit more work on the Counterstrike. I appreciate you coming on here with me today, Billy.
It helps time, buddy.
Yeah, all right. It appears the GOES is going back up again right now. So, all right. Well, I'll catch you guys in the morning.
Take it easy, bro.
All right. See ya.